Now, software development life cycle. Everything has a life cycle. May it be a human being, may it be any gadget. So there is first phase, creation, and then followed by various stages of life, and finally uh, death or destruction. That is how our SDLC, that is software development life cycle, goes. Right from the analysis phase to design, implementation, testing, and then evaluation. There are various phases of software development life cycle. So we'll look at the introduction, the history, what is Sdlc, software development life cycle, the phases, and the model of Sdlc. What is Sdlc? Sdlc is a process used by software industry to design, develop, and test high quality softwares. Now, this is very important. Why we are saying this, that we are doing it for high quality softwares? Okay, there is always some problem. Previously, when software were developed, let me read this line, then you will be able to explain more. The SDLC aims to produce a high quality software that meets or exceeds customer expectations, reaches completion within times and cost estimates. So high quality software within time and cost estimates. So usually in the earlier times, the cost overruns were there and the project could not complete within a given time. So what is the use of that software? Always cost overrun, always time overrun, and not of very good quality. For that, SDLC came into picture. Now this SDLC, which is an acronym for software development lifecycle, it gives a way, it gives a framework, it gives a guideline for a software to be made high quality, in limited cost budget, and without crossing the time estimated. This is called a software development process. This SDLC is a framework which I just indicated. Framework for defining tasks performed at each step. Every step is defined in software development process. You need to have a standardized, this framework or the set of rules, guidelines. So ISO IEC 12207 provides it. This is an international standard for software development, life cycle, and it aims to be the standard that defines all the tasks required for developing and maintaining software. So you'll get in this ISO IEC 12207, and you will get all those things, all those definitions for developing and maintaining the software. SDLC is a type of methodology used to describe the process for building information system. Previously I'm talking about the history, and it was intended to develop information system in a very deliberate, structured, and methodical way, entering each stage of the life cycle. At every stage, the processes are well defined, well deliberated, and follow certain method. According to Eliot, the traditional life cycle approaches to system development have been increasingly replaced with the alternative approaches and frameworks. That is what we are talking about. We are going to see various SDLCs in the later slides. So this attempted to overcome some of the inherent deficiencies of the traditional SDLC. These are the inherent deficiencies, and these deficiencies are, which I just discussed, the quality issue, the cost issue, and the time issue. So SDLC is a process followed for a software project, a program or application within a software organization, and it consists of a detailed plan. This is very important. Detailed plan is there describing everything like developing, maintaining, replacing, and altering or enhancing your software. So life cycle defines a methodology for improving the quality of software and the overall development process. So you will be hearing about the quality, the cost, and the time every time you are talking about SDLC, because this is why SDLC came into picture. So this is the infancy. This is a mature stage. I'm not saying it is going to die, because software ultimately replaces another software. But let me start with this. Before we can start any software making, we can even think there has to be a requirement analysis. What are the requirement? On basis of the requirement, we make design, and on the basis of design, we implement, we code, we make program, we automate it, and then when we make it, we send it for testing. And now testing has been done on the program which has been made, or the application of the software that has been made. And finally, once it has been approved or qualified with all the requirements, then the maintenance is carried out, and this process is quite long. So let us start with the first aspect of SDLC, that is first stage, requirement gathering and analysis. Now in this, all the requirements are gathered. These are the requirements from the project managers and stakeholders. So project manager actually sits with the stakeholders, with the people from whom you are making your software. And these meetings with managers, stakeholders and users are held in order to determine all the requirements, and this may take a lot of time. But the requirement is actually the basic building block of your software. Now, the next step is to design. In this phase, the system and the software design is prepared for or from the requirement specification, which was studied in the first phase. First phase requirement is an input for the design, software design of the second stage. So software design helps in specifying the hardware, software requirement, and also helps in defining overall system architecture. Then system design specifications serve again as the input for the next model which is coming. So every phase is well defined, well created, well managed. Then comes the implementation or coding part. Now if you have a good design for a good requirement, there will be no problem in implementing or coding. So on receiving system design document, the work is divided into modules, units, and actual coding is started. Actually coding is done. In this phase, the code is produced. So this is the main focus for the developers, not the designers but the developers, because this is actually the point where your software is actually made. Other phases are supporting phases, but this is where you actually code. People actually write the program or software which is required. So implementation coding is an important aspect, though it takes a very short duration in the SDLC. Then comes the testing. Now you have to verify it. You have to validate whatever has been made. So after the code is developed, it is tested against requirement to make sure that the product is actually solving the need addressed and gathered during the requirement phase. Whether the product is right or whether the right product has been made has to be taken care. And this phase, the software is subjected to various types of testing, like unit testing, integration testing, system testing, acceptance testing, and various other testing. Now comes the maintenance. Your software has been made, it has been tested. Once when the customer starts using the developed system or a software, then the actual problem comes up and then needs to be solved from time to time. It's not that you have made a software and you just deliver it and just go for some other software. No, the problem starts now. You have given the software. Now the software needs change time to time. There may be bugs, there may be problems which you need to address and remove. And this is called the maintenance. So this process where the care is taken for the developed product is known as maintenance. There are two types of maintenance: preventive maintenance and corrective maintenance. Now let us look briefly about the models which are available in SDLC. Various models which are followed by various companies, various organizations which are following SDLC. So let us start with waterfall. This is a simple goal. You have, the figure I showed was actually the waterfall model. It has a simple goal, simple to understand, clearly defined stages, well understood milestone. Waterfall, like water is falling, so various stages: one stage, second stage, third stage, fourth stage, and last stage is at the bottom. The disadvantages are, because if it has no disadvantage, why would other SDLC came into picture. So, well, this is a strong building block. This is a strong model. But let us see the disadvantages. It is difficult to measure progress within stages and cannot accommodate if the requirements are changing. And no working product is produced until late in the life cycle. So need to go to all stages, then only the software is produced. The risk and uncertainty is high with this process model. Then comes the incremental model, means you make it, then increment it, then make it, then increment it. So every time you produce a version with certain increments. The advantages are some working functionality can be developed quickly and early in the life cycle. So users are able to see what you're going to make. And results are obtained early and periodically. This line supplements this. And parallel development can be planned and progress can be measured. So all those problems are somewhat being rescued in incremental model from waterfall model. The disadvantages are more resources may be required, although cost of change is lesser, but it is not very suitable for changing requirements. And more management attention is required in incremental model, because every time you increment it, you make certain changes and you increment it and you produce it. Then you come evolutionary models. The advantages is the risk analysis, because everywhere risk is involved, and changing requirements was not well supported in our waterfall model, not now in our incremental model, so it supports changing requirement. Initial operating time is less. There are some disadvantages also. This is not suitable for smaller projects, and management complexity is quite high, and the project may not be known which risk is and can be costly in use. This is spiral, and spiral model is like a spiral. We have various 4 quadrants, and every quadrant has its own life cycle, and main thrust is on risk analysis. So advantages is changing requirements can be accommodated, allows for extensive use of prototypes. Various prototypes are produced at every stage, and requirements can be captured more accurately, and users see this is quite early. But the disadvantage is management of this kind of SDLCs are quite complex, and end of project may not be known early, because it is a repetitive process and not suitable for smaller low risk budget. Exactly, the process is somewhat complex. Then comes the RAD, that is rapid application development. Advantages are time to deliver is less, because the name suggests rapid application development, and changing requirements can be accommodated and progress can be measured. Disadvantages is management is complexity is more, resource requirement is more, suitable for systems that are component based and scalable, and suitable only when requirements are well known. Then comes the extreme agile development. Extreme agile development, as the name suggests, it is extreme, very agile, very flexible, fast development. So it promotes teamwork and cross-training, and functionality can be developed rapidly in a fast-forward manner and demonstrated. Resource requirements are quite minimum. But there are certain disadvantages also. Not suitable for handling complex dependency. More risk of sustainability, maintainability, and extensibility. So an overall plan and agile leader and agile program manager practice is a must, without which it will not work. So in conclusion, software development lifecycle is a process of developing information system, or a computer software, or an application software, or a web software through analysis, planning, design, implementation, integration, maintenance, and testing of software application. So scope can be restricted through SDLC. There can be a progressive enhancement, a predefined structure of SDLC as various models suggest, and incremental planning at each of the stages. This is what is important in SDLC. Thank you so much. Hope you got a simple idea about what is SDLC. Not lot more to be studied, because this was just a brief introduction. Thank you so much. Take care.